This is the last video clip for the laws of indices. The last law we are going to look at is a law that states that any number raised to the power of 0 is equal to 1. Yes, any number at all. Now this law has been true even before now, even while I was in the chromosome stage, up to this old age, and I'm very sure this rule will still remain. It simply states that what? Now you have a number, whatever you want to call it, say 7 raised to the power of 0, that will give you 1. You say a million raised to the power of 0. The rule simply humbles this large number and say you are 1. You have a number like 0.00001 raised to the power of 0 is equal to 1. Wherever you take it to, once the number is raised to the power of 0, the value is 1. So that's it there. 7 raised to the power of 0 is 1. 24 raised to the power of 0 is 1. Now with that we come to the end of the what? Laws of indices. Next we are going to look at solving some expressions that have to combine all these laws we have been looking at in the last 4 video clips. I think this is the 5th video clip. First, let's have a review. The first rule there, we had that a raised to the power m times a raised to the power n simply says that we should do what? Add up the two indices. Now when you are dividing, a raised to the power m divided by a raised to the power n simply says subtract the index of the divisor from m. So we have m minus n. And that's this other two handles the negative index rule. And here we have the fractional index rule that says a raised to the power 1 over n is the nth root of a. And my wonderful rule, I love this so much, multiple indices rule, a raised to the power m or raised to the power n is equals to what? A raised to the power, the product of m and n. And here, the combination of both the fractional rule and the multiple indices gives us that a raised to the power m over n can be expressed as the nth root of a or raised to the power m. And finally, we came to this powerful rule that a raised to the power 0, any number at all raised to the power of 0 is 1. Now let's simplify this simple expression here. We have there that minus 4 u square v raised to the power 3 all raised to the power of 2. Now we have to distribute this. Now this bracket is simply saying that the raised to the power 2 belongs to everybody. So I'll say, okay, that means minus, you have to be raised to the power of 2, 4, you have to be raised to the power of 2, u square, u2 have to be raised to the power of 2, v cube also has to be raised to the power of 2. Now minus raised to the power of 2, minus times minus is plus. Now anytime a negative sign is raised to a number, if the number is even, to give you positive, if it is odd, to give you negative. So this means positive, so I can just forget about this. 4 raised to the power of 2 is 16. Here we have u raised to the power 2 or raised to the power of 2. So we apply the multiple indices rule that says we have here u raised to the power 2 times 2. Similarly, this will be v raised to the power 3 times 2. And you will agree that our final answer here will be 16, u raised to the power 4, and v raised to the power of 6. That's so interesting. So that's it there. Yeah, our minus 4 square give us 16. U raised to the power 2 or raised to the power of 2. 2 times 2 is 4. And 3 times 2 there is 6. Next on the screen, we are asked to simplify 8 over 27 or raised to the power of minus 2 over 3. You can see negative index, and we can see a fractional what? Exponent. Let's take them one after the other. If I were you, I would first and foremost deal with the negative index. If you remember very well, when we have a negative index with a fraction, this negative, you have to say, let me throw you away. It says 1 all over Okay, or you just simply roll 27 over 8 there. But let's take it step by step. Minus says this is going to be 8 all over 27. 1 all over 8 over 27. And then, of course, our exponent is there, 2 over 3. And then this is simply saying 1 all over is still there. Now, when we have 2 over 3, what does it imply? It means the cube root of, forget that, the cube root of, what rule am I applying now? I'm applying this rule. A raised to the power m over n is the nth root of a, all raised to the power m. So 8 over 27, all raised to the power of 2 over 3, is the cube root of 8 over 27, all raised to the power of 2. And of course, where can we simplify this? Let me write there. That will be 1 all over. Now the cube root of 8 is 2, and the cube root of 27 is 3. So that will give me 2 over 3. Then remember, raised to the power of 2. And I have this as 1 divided by 2 raised to the power 2 is 4. 3 raised to the power 2 is 9. And this will roll over at the end of the day as 9 over 4. We've learned that in primary school. Let's see. Okay, step by step here. What can we see? The negative sign is being handled there first. And we have 1 all over 8 over 27, all raised to the power of 2 over 3. The next thing is there. So, okay, in this case, we rolled over straight away because 1 all over means reciprocal of 8 over 27, and that gave us here 27 over 8, all raised to the power 2 over 3. And then we take this straight to what? The cube root of 27 over 8. That's what is being done there. And then raised to the power of 2. Remember, we are applying this rule right now on this expression. And cube root of 27 is 3. Cube root of 8 is 2. And remember, we have raised to the power 2 standing there. And that gives us 9 over 4. Very splendid. You can see how combining these rules or laws can help us to simplify some composite expressions. Let's look for another one. Here we are told to simplify 0.125 raised to the power of minus 1 over 3. At first, you may want to run away, but do not. Simply look at 0.125 first. As I'm going to turn you to a fraction. And I remember when I was in nursery 2, I was told I can write this as over 1,000. That's all. With that, I'm okay. I said, okay, that means 0.125 raised to the power of minus 1 over 3 can be written as 125 divided by 1,000 raised to the power of what? Minus 1 over 3. I said, okay, next I deal with the negative sign. The negative sign is simply saying, man, roll this thing over. Reciprocal. 1,000 divided by 125. Okay, now that I've done that, I have 1 over 3. And what is this saying? This one is simply telling me take the cube root. I said, okay, so that means this will be the cube root of what? 1,000 all over 125. Without consulting any oracle, I know that the cube root of 1,000 is 10 and the cube root of 125 is 5. So I have 10 over 5 there and the answer is 2. Isn't that splendid? So that's it there. First and foremost, the decimal is dealt with and we have this as 125 over 1,000. Next, we deal with the negative sign and reciprocate here, 1,000 over 125. So the next thing is to do what? Advance and turn this to what? The cube root of 1,000 over 125. So let's look at that in the next slide. There, that's it. Cube root of 1,000 over 125, and that gives us what? That gives us 10 over 5. And I remember very well, even my grandmother will remember this to be 2. So that brings us to the end of introduction to indices. From the next 3 video clips, rather, we'll focus on equations involving indices. Some people call it indicial equation, but it's more popularly expressed and addressed as exponential equation. So see you in the next video clip.